Dr. Pavitra Bharadwaj. I work as an associate professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So, friends, in the series, continuing ongoing series, we are talking about Python programming, and we are now talking about how Python can be used for analysis and visualization of data. So, before we actually go for analysis using Python, we first need to understand what is the meaning of data analysis. And we had seen in the last lecture that data analysis is a composite process which involves multiple steps. So, the first step in data analysis is data collection, and the last lecture we had discussed in detail about what are the various methods which can be used for data collection, what are the tools which are used for data collection, and what are the important points to remember while data collection is being carried on. Now, today we come to the second part of the process of data visualization and analysis. We talk about data cleaning. So, data cleaning is a very critical process in the data analysis because it involves preparing and refining the data to ensure that it is accurate, consistent and usable. So, clean data is very essential for producing reliable and valid results. So, if your data is not correct or it is not consistent, then you cannot expect that you will be getting the correct outcome or you will be getting the correct results from the analysis process. So, therefore, once the data is collected, now whether the data came through a survey or it came through an experiment or it came through observation, whatever method was used to get the data, it is finally available to us in say an Excel sheet or in a Google spreadsheet, in whatever format. Now, we come to the step of cleaning the data so that we are sort of preparing this data and making it usable, making it reliable for obtaining the desired results. So, data cleaning is a very important process because it will ensure that there is accuracy in the data, that the data reflects the true values which are to be used. Then it is needed for maintaining the consistency of the data, that is to make sure that data is uniform across the data sets. Then completeness of the data is also determined when you are doing the data cleaning, that is there are any missing data or any incomplete data which has come into your data set, and of course, we need to ensure the reliability to improve the trustworthiness of our data analysis. So, these are some important points, some important outcomes which will come in when you are using a proper data cleaning technique. So, when you look at data cleaning process, so there are multiple steps which are carried out in data cleaning, and actually in data cleaning you sort of try to handle the different kinds of problems which may have come into the data. Like for example, you do not have certain values, that is there are some values which are missing values, or some values are incorrect values, or some values are say outliers. So, these can be different types of issues which you may see, or different kinds of problems which you may see in your data set once you get it for cleaning. So, the first step, that is first problem which we see is the problem of missing values. So, how do you handle the missing values? So, there can be different approaches for handling missing values. The first is that you simply delete or remove the records which have got the missing values. So, you can have a list wise deletion, that is exclude the entire record with any missing value, or you can have pair wise deletion where you exclude the data only in analysis where values are missing, right. So, basically what we are trying to do, wherever a value is missing, we are going to just omit that particular record. Then you have imputation. Imputation means that wherever there is a missing value, you sort of try to replace it with an estimated value. Instead of deleting the entire record or instead of deleting the pair, we will try to insert a value, an estimated value in place of the missing value. Now, how do you insert or how do you estimate the value that needs to be inserted? So, that could be simply by finding out the mean, mode or median of the entire data set. Okay. So, we can use these statistical measures and fill in the missing value, or we can have a predictive imputation, that is we use an algorithm to predict the missing value based on the other data. So, we have a complete data set and we want to find out a few missing values. So, we just simply use a prediction algorithm and predict the value, or we can have the k nearest neighbors, that is you impute the missing values using similar instances, that is you look at the data set and the values which are which are close to the missing value, you just impute those values into it. So, in case of Python, this is a simple code which shows how we can actually do this imputation using the Python code, right. So, if you look here, we are simply importing pandas as PD. So, pandas basically is the Python library. We will be discussing this later on also when we will be actually doing the data analysis questions or programs. So, here first thing that you do is that you load the data set. So, here we are trying to read a CSV file, a comma separated file, that is called data. So, we read this file and we load it into a data set called df, and now we are trying to impute the mean value wherever there is a missing value. So, we are writing df.fill_na, df.mean. So, we are using the mean function and we are imputing the mean into wherever places, in whichever places the value is missing. So, wherever you have a missing value, it is going to put in the mean of the value, or the other thing is that you simply drop that record. So, we are saying df.drop_na in place of true. So, wherever the value is a missing value, you simply drop that value. So, these are the two approaches which are commonly used, whether you are whenever there is a missing value, either you use the deletion or you use the imputation. Now, there will be scenarios or there will be situations in the data where we are seeing duplicate values, right. That is, same values are showing for different records, right. So, here you need to remove the duplicate. So, there are two techniques which can be used. First technique is to identify the duplicates, that is we find and we review the duplicate records, and in the second we try to remove the duplicate, that is we only will try to keep the unique records. So, again for Python we will use the function drop duplicates for dropping the duplicate rows from the data set. So, wherever two rows are exactly similar, this function drop duplicate is going to drop it. Then we also need to have mechanism where we can correct the data type, right. Sometimes the data type is not appropriate. So, what you do is that you need to ensure that each column has appropriate data type. Like for example, you have string and date functions, right. So, you have date and time conversion. So, you will convert the strings to date and time object. So, this is another kind of problem which you see, that dates are often shown as strings. So, you want to convert them so that you can work on them. So, for this again we can use a simple Python code can be used, where we say we choose the data set and we say date column and we convert the string into date and time format, or you convert the number into a floating point format. So, basically what we are doing here, that we are changing the type of the data which is there. Then we can have a problem of outliers, right. Now, what are outliers? Outliers are any values which are outside the normal distribution of the sample values that we have collected. So, say for example, if all the values are in the range of 0 to 10, then a value of say 100 would be an outlier, or a value of say -10 would be an outlier. So, what we need to do is we need to use statistical methods or visualization to detect outlier, because if you plot the data in a graph using the visualization tool, then the outlier is going to lie far away from the curve, or it is going to lie far away from the line. So, we use the Z score in case of handling outliers in Python. So, Z score means where the value is more than 3 standard deviations from the mean. So, you calculate the standard deviations, and if the value is 3 deviations away from the mean, we say that the Z score of the particular data item is high. So, therefore, it is an outlier. The other method of identifying outlier could be the interquartile range method. So, you have values which are outside 1.5 times the interquartile range from the quartile. So, then that value is also said to be an outlier, and that value also needs to be treated, right. So, now what we need to do is, for outliers we need to decide whether to remove the outlier, or you decide whether you want to correct the outlier based on the context. Because why we say this is because sometimes the value which appears to be an outlier is not an outlier, but it may be an actual relevant value. So, it is very important that when analysis is being done, the outliers are very carefully dealt with, so that if it is a value which is experimental value which can lead to more insights into the data, then that value should not be omitted. But if first thing is that you can detect the outlier, right. So, we detect the outlier using the Z score. So, here again we will use the Python libraries SciPy and NumPy. So, we import the two Python libraries, we calculate the Z score, right, and if the Z score we have seen that if it is more than 3 times, then we say that the value is outlier. So, if it is less than 3, if the Z score is less than 3, then we can consider that the value is within the range of the data. And once you have detected the outliers using Z score, then you need to take a call on whether you need to delete the outlier or you need to put it inside your data, you want to make it a part of your data set. You can also use the interquartile range method for detecting the outlier. So, you define the quantile range, and using that range you can specify whether you want that particular column or not. So, once you know that the data requires some kind of change, or while you are cleaning the data, another very important step that you have to follow is the standardizing and the normalizing of data technique. Now, what is standardization of data? That is, you adjust the data to have a mean of 0 and a standard deviation of 1. This is called standardization. That is, you put a formula for mean and standard deviation, and then you sort of try to adjust your data to come into the mean value of 0. So, normalization means that you scale the data to a specific range. So, we are typically bringing the data into the range of 0 to 1 when we are trying to normalize. So, again Python provides us with a lot of ready-made library functions which can be used for standardizing, for finding out the minimum maximum scalar can be done, or the transformation of the column can be done using the ready-made functions which are there in Python, right. Then sometimes we also see that there are inconsistencies in the data, that is, the data values which should be same in the two data sets, they are not the same, they are not consistent with each other. So, first thing that we do is that we try to standardize the format, right. We have already seen how data standardization is done. So, we ensure that the values are consistent, the formatting for date and text etc. is consistent, right. The correct type of typos are used, that is, we identify and correct misspellings and inconsistent entries. Sometimes it is only a typing error which can lead to this kind of inconsistency, and then we try to standardize the text entry. So, we know we can standardize the numeric entry by finding out the mean and standard deviation, and for text entry, say for example, if you want that the text should be in the lower case only. So, what you can do is you can make correction and you can convert your text into the lower case by using the relevant functions, right. So, in data cleaning basically Python libraries are a very important tool when you are trying to clean your data set. So, in Python basically we are talking about, we have seen also that two important libraries are very important. You know, they play a crucial role for data cleaning of the sets. First is the pandas library, that is for data manipulation and cleaning only. So, the pandas library provides us with a rich collection of functions for different types of data cleaning activities and also data manipulation. Then we have the NumPy, which is basically used for numerical operations, and we have the SciPy, which is used for statistical operations like for calculating the standard deviation or for calculating the mean. So, these three libraries in Python, pandas, NumPy and SciPy, they provide a whole range of functions which can prove very important for data cleaning activity. Other than this, we have other softwares also which are available, like we have the OpenRefine software for cleaning messy data. We have the Trifacta software which is used for data wrangling tool that helps with data preparation. So, this can also be used, and of course, we have some simple Excel tools, like there are some built-in function using, you know, like the if function or the VLOOKUP or the text to column functions, which can also act as an important, you know, aspect or an important feature when you are wanting to look for simple data cleaning tools and your data set is an Excel data set. Then we also can go for advanced data cleaning and transformation using another software, another tool called the Power Query tool. So, these are some of the tools which can be used, whether you can use the Python libraries or the Excel, or you can use other softwares which are available for your data cleaning exercise. So, once you have cleaned your data, then you actually move on to the exploratory data analysis phase. So, this is actually the third phase in data analysis. So, in exploratory data analysis, basically it is, you know, it is a process where analysts investigate and summarize the main characteristics of a data set, right. So, actually if you see, this is the step from where the real analysis begins, collecting, and then we were in the cleaning phase, we were sort of prepping up the data. Now, we are actually investigating, we are summarizing the characteristics of the data set. So, what is the goal? The goal basically of the EDA is to gain insights, identify patterns, detect anomalies and test hypotheses using various techniques before applying formal statistical methods, right. So, after EDA will come the statistical methods, but before this we are actually looking at if, you know, we can test our hypothesis using the data, you know, if the data is showing any kind of anomalies, or what are the patterns and insights, you know, one can get from the data set that is under the scanner, right. So, EDA, exploratory data analysis, is a very important step because it allows us to understand the data, it gives us a deep understanding of the structure and attributes of the data set. It also allows us to identify, recognize any kind of trends or relationships or patterns which may be there in the data. So, potential areas for further analysis can also be identified in this step only, because after EDA we will take the data set for any kind of statistical analysis, right. So, any pattern recognition or any relationship or any trend that you want to see, you can easily witness it in this step of your EDA. So, again in EDA it is also very important because it helps you to find out anomalies, like we just discussed the idea or the concept of outliers. So, what are outliers? Outliers are basically any unusual data points which may require special attention. So, sometimes these are also known as anomalies. So, when you are looking at the data in the EDA, you actually pay special attention to the outliers, whether they need to be overlooked or they need to be made a part of the data set. And then we also prepare the data for the modeling, that is, we inform decisions about data transformations and feature selection for predictive modeling. So, after the EDA is done, then statistical analysis and modeling of the data can be taken care of. So, in EDA we have several techniques which we follow. So, the first and foremost technique is the descriptive statistics technique. So, here what we do is, because we know that in EDA we are sort of trying to summarize the main features of a data set. So, what we do is, we look at certain measures of central tendency. Now, we all know that in statistics the main measures of central tendency are the mean, the median and the mode. So, mean basically means that you find out the average value, median means that you find out the middle value of a data which is sorted, and mode is the most frequently occurring value. So, these these measures, that is the mean, mode, median, they will give us a summarized view of your data set, right. Then we also need to look at the measures of dispersion, that is how the data is dispersed. So, we need to find out the range of the data set, that is what is the difference between the maximum and the minimum value, so that we get a range of the entire data set. We need to find out the variance, that is the spread of the data values within the data set. We need to find out the standard deviation, that is we need to find out the square root of the variance, and we also need to find out the interquartile range, or IQR what we call as, that is between the first and the third quartile, what is the difference, what is the range between the two quartiles. So, all these methods, whether range, variance, standard deviation or interquartile range, they will give us the right measure of the dispersion of the data. Now, again these functions are also there, they are also available in your Python library. So, we already know that you use the Python pandas library to find out the range of these. So, you can find out the mean, the median, the mode, standard deviation, range and the IQR using the ready-made functions which are there in the pandas library. Use all these descriptive statistics can be found. Then we come for the data visualization. So, visualization basically means to create visual representations of data to identify any patterns and relationship between the data. So, here we are going to look at three types of analysis which can be done. So, you can have univariate analysis, you can have bivariate analysis and you can have multivariate analysis. So, in each type of analysis there are different types of diagrams or different types of patterns that will be emerging, right, different types of visual representations which will be used. So, in univariate analysis the first we look at is the histogram. Univariate basically means that you are looking at the distribution of a single variable. So, in histogram we are looking at the distribution of a single variable. Then we have the box plots which show the distribution, spread and identify the outliers. So, in box plot also we are looking at one variable, but we are looking at three attributes of the same variable, that is how the variable is distributed, what is it is spread and what are the outliers. Then we have the density plots which estimate the probability density function of the variable, that is in this we find out what is the density or what is the function which can be used to estimate the probability of the variable. Then in case of bivariate analysis where you are examining the relationship between two variables, here you can have scatter plots which is you examine relationship between two continuous variables. Bar charts are there where you compare categorical data, that is two parallel bars are seen, and then you also have the pair plots where you show pairwise relationships and distributions in a data set. That is, you have two values which you want to show, like for example, you want to show rainfall and agricultural production over say the past 50 years. So, then these are pair plots which you can see and you can visualize. And then finally, we have the multivariate analysis which can be shown, which can be plotted using heat maps. That is, here you are visualizing the correlation between multiple variables together. Then we have the principal component analysis or the PCA analysis, which reduces the dimensionality and visualizes the high dimensional data. So, again we have in Python, we have a library called the matplotlib, right. So, this is a visualization library, and we can import objects from this library to plot the different kinds of diagrams or the different kinds of representations, whether it is histogram or the others. So, in this particular discussion, we have talked about the various steps which need to be undertaken for analysis of the data sets. Before actually you begin analysis, you go for collection and cleaning, then you go for exploratory data analysis, and after exploratory data analysis has been done, you go for statistical analysis, and then finally using the various Python libraries you can go for data visualization. So, we will be continuing with our discussion on this in following lectures. Please keep watching CEC. Thank you.